put quite as expend quite as much engineering effort in order to monetize across multiple platforms. So it's a good thing. Okay, so beyond graphics, Adreno 320 for the first time is able to be used as this general purpose processor, and that's primarily useful for now. We're seeing from different ISVs and OEMs who are experimenting with OpenCL in particular on our platform is for things like cloning objects and recognizing an object in the scene and cloning it, removing objects from a captured image. If you took a picture and there was really poor lighting, can you apply a filter that removes some of that noise and results in a higher quality image? Some of the other applications are, if you, which will really change, I think, the usage profile, that you don't have to actually focus. You take a picture, then later you focus, and this OpenCL will allow this highly computationally intensive algorithm to then kind of zoom in selectively on an area that you really want to focus. So the entire light field, for example, in the image is captured. So it's kind of exciting. It's one of those things where the technology is out there, and now developers will start utilizing it, I think surprising us with what can be done. So there are two APIs for this, OpenCL and then RenderScript Compute. So OpenCL is the Chronos standard, and then RenderScript Compute is Google has taken a look at GPU type APIs, parallel computing APIs, and they've abstracted a few things into the Android runtime and framework to make it so that it's much easier to program these kinds of computationally intensive parallel computing, imaging, and video post-processing type use cases. So, both of them are good. We're going to support both of these. We have customers asking for us to support both, so we intend to. 5 minutes. Okay. All right. Transitive benchmarks. All right. I want to hit this a little bit. First of all, I want to say something. Benchmarks are not a means for hardware vendors to clobber each other over the head. I think sometimes that gets played out. I think it's fun to talk about that kind of thing, but it's almost like when you watch a football game, you kind of assume the guys in the field don't like each other, but at the end you see them all out there shaking hands. We are sort of in this together, and the more we can standardize on the types of tests that we have to tune for, the better off each company is going to be. The more accurate those tests are, the more representative they are of real content, the better we'll be able to design hardware and drivers and compilers that meet the needs of our customers and improve that experience. That really is what motivates it. This other part is just a fringe, a 2% of the problem where we have some insidious things that go on between hardware companies, but it doesn't happen nearly as often as you might think. Anyway, so what's a well-written graphics benchmark? It's one that basically predicts performance of real-world applications. It needs to be written with a relevant API, one that's current, OpenGLA's 2.0 or 3.0 in the near future here. It should be written with fundamentally sound design practices for GPU in mind. And there are certain things that if you've been programming for GPUs for a while, you just know there's certain things you do and you don't do. If you're brand new to programming GPUs, you don't know that, and you end up creating a so-called graphics test, which really doesn't stress the GPU at all. It's just sitting there burning cycles on the CPU and trying to fetch things from memory in a very inefficient way. So it also should include things like frame counter, some types of metrics that ensure correct conclusions, and it should run on some of the latest OS targets, so that you're not just testing, gingerbread versus ice cream sandwich. So appropriately designed benchmarks for GPUs, they're generally designed by a few companies. We have Rightware here today. I'm very happy about that. I think that they have some excellent engineers. Kashanti is another one. Tactile's another one. These are companies that know how to make commercial-grade graphics engines. They know how to program GPUs. They have good artists. They make intelligent decisions about the loads that are very representative of real-world games. And they're useful for us for driver development. So that's where we primarily engage with them, is to help us stress our product and make it better. So poorly designed benchmarks, and unfortunately more and more of these appear each day. It's really unfortunate because it kind of drowns out the good ones, the ones that are actually really useful to experts like us for to make better products. They get drowned out by some of the inferior ones. And there is sort of a commonality between the inferior ones. They tend to be tend to have very poor coding practice, and the revision control is really bad. So you don't even really know what you're testing sometimes. They could churn out 4 or 5 different versions of them. And they don't really represent real-life scenarios of graphics UIs or games. For example, they may have 2,000 draw calls in a frame, whereas 75 to 200 is kind of typical. That probably captures a very large range of the GPU applications. So whenever something is not really representative of real-world content, it is helpful when you guys recognize that, so we don't get pressure to try to design products to get high scores on things that really don't improve the user experience in any way. So this is an area where we definitely like to talk more with you if you have questions. So evaluating graphics performance is pretty simple. You do want to use graphics benchmarks appropriately. You do want to run all the good ones. You want to kind of take an average because they all stress the GPU in slightly different ways. They all stress memory subsystem and CPU in slightly different ways. Don't ever just look at a single benchmark. Make sure that you're looking at a bunch of them and draw the conclusions from some sort of an average. I would say there's definitely no substitute for testing commercial content on smartphones and real commercial tablets. Make sure you test a few different ones from different OEMs. Just basic things. Pretend like you're a consumer. Can you load the games? Do they play smoothly? Is the UI and browser scrolling responsive? How does the battery life compare to other devices? I'm going to skip over this really quickly, but there's an aspect of the ecosystem that's very important. You have to do more than just provide a chipset and a driver. You have to provide hardware tools and software tools. We can also make these available to you guys. So if you're a tinkerer and a blogger, we really encourage you to get your hands on some of this collateral, and we can tell you how. We have some other collateral like the Snapdragon Game Command application, which helps you go out and find, aggregate different games which we know that have an excellent user experience on Snapdragon, provide some game industry news, some other kind of value add that we provide that's useful. Okay, so in conclusion, Qualcomm's new Adreno 320 Snapdragon GPU for S4 is here. We're very excited about that, something we worked on for a very long time, and we're very proud of it. It does support new features. It supports unified shaders in an even more performant way than before. It supports this new Flex Render technology, GPU with OpenCL and RenderScript, this new graphics API, the OpenGLA's 3.0, codenamed Halti for the time being, and then 3 to 4x better performance than previous Adreno GPUs. We've expanded our ecosystem support, and very importantly, we want to work closely with you guys as you evaluate our products. If you have any questions, you can come to us. We will answer your emails. Hopefully, we'll answer them quickly, and that's about it. Any questions? Go for it.
Okay, I've got 3 this time.
Okay.
First of all, regarding non-game applications that are accelerated on the GPU, when Google launched Android 4.1, I was a little unclear as to whether the Project Butter UI enhancements used the GPU. And could you tell me whether Project Butter and the improved UI takes advantage of advanced GPUs, or is that still all on the CPU?
Yeah, I don't know so much about that particular UI. I can tell you in general, Android UIs, they are GPU accelerated.
Okay.
And not just for the drawing, but also for the composition.
Okay. Okay. Now, when you talk about the hopefully standard texture compression methodology,
right.
If this becomes more common, does this mean that we're going to see those gigantic supplemental collateral game files become smaller? A lot of high-end games now are downloading these like 250, 500 megabyte files, which aren't that practical on small storage devices. Does this reduce the size of those files?
It definitely has that potential if that's what the publisher decides to do. I mean, the textures are a huge part of the total size of the game. Okay. So if the standardization takes off, as I think it will, it definitely will. Definitely has a potential to make these downloads smaller. Okay.
Okay. And finally, when you were talking about OpenCL and the GPU support, you mentioned light field photography, and I thought that needed special hardware, and right now it needs a lens that's that deep. So how does this enable light field photography? Does this enable light field photography without the wacky Lytro hardware?
You can think of this as downstream processing. So we're not making the lenses or the imaging hardware. Once that image is acquired, what OpenCL or RenderScript compute as an API does is it allows you to then manipulate that data using the significant SIMD processing capabilities of the GPU. So we're not making the upstream hardware for that. I mean, Lytra is a company that makes that. But we do offer the APIs and the underlying compiler and driver support for them to manipulate, companies like them anyway, to manipulate those images to make some nice effects.
But just to be completely clear, you could still do that kind of computation on a CPU without GPGPU. It would just be slower, right?
You'd be definitely more limited. I mean, and you also could do it without using either the APIs